Hi Math 2 students. Today we are going to go over how to use the quadratic formula to find the solutions of a quadratic. So far we've learned a couple of different methods on how we solve a quadratic. The first is factoring, where you factor it and set each factor equal to 0 and go from there. And then the other one was taking the square root of both sides, okay? You start out these problems pretty similarly to how you would start a factoring problem. Is you need to make sure that it's set equal to 0. Now, in this case, it is set equal to 0 already. So we don't even have to do that. We just get 5r squared plus 8r minus 1 is equal to 0. And that's taken care of now. Next, we are going to identify our a, b, and c. We've already done this when we identified our discriminant, right? So we can see that our a value here is going to be 5, our b value is 8, and our c value is -1, okay? Now we are going to plug into the quadratic formula. This is the formula for quadratic formula here. We say it's -b plus or minus the square root of b squared minus 4ac all over 2a, okay? So let's go ahead and put these, I guess I'll drag this down so we can see it as I'm plugging it in. So we have -b. What I recommend you kind of think of that as is just opposite of b. So if b is positive, you're going to put a -b. If b is negative, you're going to put a positive b here. So since b is positive, we switch the sign of it and we get a -8. Now, one thing I want you to make sure you do is we need to put parentheses around that b squared. Sometimes it's not going to matter, but sometimes it does. Basically, if that b is negative, you need to have those parentheses, so just get in the habit of using those parentheses, okay? So we do -4 times, and we do our a value times our c value. And then it is all over 2 times our a value. So all we did was we took these a, b, and c values and plugged them into the formula. Now, hopefully you noticed that this part inside of the radical here is the discriminant. We've already practiced finding the discriminant, okay? So keep that in mind. So once we plug everything in, we are going to get, I call these like our 3 values, okay? This value is going to stay the same, but we need to plug this into our calculator to find the discriminant. Now, when you plug this in, you do not plug in the square root symbol, okay? Just find the actual discriminant like we've been doing, right? So that's just b squared minus 4 times a times c. Ooh, I did not type that in right, sorry. All right, so when I do that, I get 84, okay? So I go ahead and I put in 84 into my radical there, all right? Then in the denominator there, I just have to do, what, 2 times 5? Okay, so I do that and I get 10. All right, so now hopefully you recognize that this looks like the problems we were working on simplifying this past week, right? So we have to work to see, okay, can we simplify this radical, right? So if I have the square root of 84, it's not a perfect square. You can try it out, right? If I do a square root of 84, it's not a nice number, so I have to go ahead and break it down. I have to find the biggest perfect square that goes into 84. So you can list out your perfect squares if you still need to do that, no big deal. 25, 36, 49, 64, 81. Okay, so we would try all of them, right? So we do 84 divided by 81, 84 divided by 64, 84 divided by 49, 84 divided by 36, 84 divided by 36. Oh, sorry, I already did that. Divided by 25. 84 divided by 16. 84 divided by 9. 84 divided by 4, and that's it. Now, if none of them work, then this actually would just be your final answer because you can't simplify it. But in this case, we can simplify, right? We end up with 4 times 21, which gives us 2 root 21. So now we've got -8 plus or minus 2 root 21 all over 10, okay? This is the lover step where we look at these 3 guys and we see what we can divide all 3 of them by. In this case, we can divide all of them by 2. So we end up with a -4 plus or minus, and then this is like 1 times root 21, so we don't need that 1 there. And then this would be all over 5, okay? Now, if you are someone that likes to split it into 2 fractions, which is totally fine to simplify, you would do -8 over 10 plus or minus 2 root 21 all over 10. Negative 8 over 10. We simplify that into negative 4/5. And then 2 over 10. We end up with 1/5, which we don't need to write that 1 because we already have that root 21 there. So you could write your final answer like this or like this. I don't care which one you prefer. Just do whatever makes you happy. All right, let's try another one. So again, to solve, we need to make sure that we've gotten it in standard form. So if we have n squared minus 27 equals 6n, we have to work to make sure that this quadratic is in standard form, which means that it is set equal to 0. Keep in mind, you want to make sure that the leading coefficient on the highest power remains positive. If it's negative when you move things over, I would move everything over to the opposite side so that this guy in front remains positive, okay? So we go ahead, we're going to subtract 6n for both sides, and we combine like terms, which there really isn't any, so we just end up with n squared minus 6n minus 27 equals 0. So now we can go ahead and identify our a, b, and our c. These are the coefficients on our quadratic here. Our a value is 1, our b value is negative 6, and our c value is negative 27. So now we can go ahead and plug this into our quadratic formula. So remember, you do opposite of b. That's what negative b means. So opposite of, in this case, negative 6, we're going to do positive 6. And then remember to put parentheses around that b squared. If you do not do that, you are going to get the wrong answer half the time. So make sure you put parentheses around that b squared. It should be like open parenthesis, negative 6, close parenthesis, and then the squared, okay? That is very important. And then we do minus 4 times 1 times negative 27. And then this is all over 2 times a. So now we're going to go ahead and identify our discriminant, right? Remember, you plug in what is inside the radical without the radical. So essentially just finding the discriminant, which is b squared minus 4ac. We do negative 6 squared minus 4 times 1 times negative 27. When we do that, we end up with 144 as our discriminant. We still got this 6 out in front, and then 2 times 1 gives me a 2. All right, so now we work on simplifying this, okay? We've got 6 plus or minus, and then we can actually take the square root of 144. That is a perfect square, which means that the radical goes away. If we do second square root of 144, you will see that that is 12. So we end up with 6 plus or minus 12 all over 2. Now, in cases where the radical completely goes away, what you want to do is split this expression into 2 expressions and finish solving, right? So we have like our 6 plus 12 all over 2 and our 6 minus 12 all over 2. Do not plug this directly into your calculator. Simplify the top, simplify the bottom, and then divide. If you plug it in right away, there's a good chance you're going to plug it in incorrectly. So on top, I get an 18. I divide that by 2. 18 divided by 2, I get 9. 6 minus 12 gives me a negative 6. Divided by 2, I get negative 3. So my 2 answers here are 9 and negative 3.